I told you that if we have natural log of A over B is also the same thing as what? Natural log of A minus natural log of what? B. You understand? So we are still going to use the same approach. And if you have a function that have natural log of A, B is also the same thing as what? Natural log of A plus natural log of what? B. You understand? Okay, now let us use the same approach here. You can see that the component that we have here is what? X squared sine 2x all over 2x plus 4. If you compare this question with this rule, you can see that A is what? X squared sine 2x and B is what? 2x plus 4. And I told you that according to the law of logarithm, if we have natural log of A over B is also the same thing as what? Natural log of A minus the natural log of B. Okay, now let us proceed. So for this, I'm going to have the natural log of x squared sine 2x minus the natural log of what? 2x plus 4. You understand? That is, according to the law of logarithm, I'm going to take the natural log of the numerator minus the natural log of the what? Denominator. Okay, let us proceed. You can see that if you look at this component, I still have the product sign is between x squared and sine 2x. And I told you that if we have a natural log of the product of A and B, it's also the same thing as what? Natural log of A plus the natural log of B. Therefore, for this, I'm going to have the natural log of x squared plus the natural log of what? Sine 2x minus the natural log of 2x plus 4. So I have decomposed. You can differentiate this function right now. You understand? You can differentiate it. But if you want to decompose it further, you can still decompose it. You can still reduce this function. For example, if you can see from this place, I can say that this natural log of x squared can be written as what? You can see? And this can be written as natural log of sine 2x minus the natural log of what? 2x plus 4. Okay. According to the law of logarithm, if we have natural log of A raised to the power of B, we can make it like B natural log of A. You understand? So I can use the same approach. I can use this approach. I can use the approach that I use there. I can use it here. So 2, I'm going to have 2 ln x plus ln sine 2x minus natural log of what? 2x plus 4. So I have decomposed this function, this complex function. I have reduced it to this form. So it is easy to differentiate this function right now. You understand? So that is the aim of decomposing a complex natural log function, so that you'll be able to differentiate it easily. So question B, decompose ln x squared sine squared pi x all over the cube root of x squared plus 2. We are still going to follow the same approach. Don't forget that when we have the natural log of A over B, it is also the same thing as what? The natural log of A minus the natural log of B. So I'm going to have for this, I'm going to have natural log of x squared sine square pi x, sine square pi x minus the natural log of the cube root of x squared plus 2. Okay, you can see that I just moved the numerator to the up and I applied the negative sign with the natural log. You understand? According to this rule. Now you can see that the sign between x squared and sine square pi x is what? Product. And I told you that when you have the product, when you have the natural log of the product of A and B, we are going to add. You understand what I'm saying? According to this rule. So for this, I'm going to have the natural log of x squared plus the natural log of sine square pi x minus the natural log of the cube root of x squared plus 2. I can write it as this, raised to the power of what? 1 over 3. I think you understand. Okay, now I want you to pay attention here. This can be written as ln x squared, I've not done anything, plus if you have sine square x is also the same thing as what? Sine x raised to the power of what? 2. Please, do you understand? If you have 2 raised to the power of x is also the same thing as what? X raised to the power of what? X. You understand? if you have sine cube x, is also the same thing as what? Sine x raised to the power of what? 3. You understand? Okay, now let us proceed. We are going to use the same approach in this place. Ln sine square pi x can be written as ln sine pi x raised to the power of 2. You understand? According to this rule. Okay, minus natural log of x squared plus 2 raised to the power of what? 1 over 3. You understand? Okay, let us proceed. Don't forget that according to the third rule that I wrote here, ln natural log of a raised to the power of b can be written as what? B, the power will come and multiply the coefficient of the natural log, which is 1, which is what? B multiplied by ln a. You understand? So for this, I'm going to have 2 ln x plus, if I apply the same rule, this rule in this place, I'm going to have 2 ln sine pi x minus 1 over 3 natural log of, 1 over 3, let me put this bracket here. Let me put a good bracket here. Natural log of x squared plus 2. You understand? Okay, we have gotten to this point. At this point, it is easy to find the derivative of this logarithmic function. That is the aim of decomposition. That is, we are to break the function down to the lowest form. You understand? Now it is easy to take the derivative of this function. Okay, we have question C. Decompose ln sine square x cos square x all over tan square x. We are still going to use the same approach. Don't forget that when we have the natural log of a over b, this can also be written as natural log of a minus the natural log of b. We are going to apply the same rule in this place. So to decompose this, I'm going to have the natural log of sine square x cos square x minus the natural log of tan square x. You understand? Okay, now you can see that the sign between sine square x and cos square x is what? Product sign. That is the multiplication sign. And according to the rule that I wrote here, natural log of the product of a and b can also be written as what? Natural log of a plus the natural log of b. Okay, so for this, I'm going to have the natural log of sine square x plus the natural log of cos square x minus the natural log of tan square x. You understand? Okay, now don't forget that sine square x is also the same thing as what? Sine x raised to the power of 2. You understand? So for this, I'm going to have the natural log of sine x raised to the power of what? 2. And cos square x is also the same thing as what? Cos x raised to the power of 2. So I'm going to have plus the natural log of cos x raised to the power of 2 minus, and tan square x is also the same thing as the natural log of tan x raised to the power of 2. So I'm going to have this tan x raised to the power of what? 2. Okay, now don't forget, when we have the natural log of a raised to the power of b, this can also be written as what? B multiplied by the natural log of a. You understand? So we are still going to use the same step in this place. So using the same step, I'm going to have 2 ln sine x, you understand, plus 2 ln cos x minus 2 ln tan x. You understand? Okay, we can factorize here. So I'm going to have 2 into bracket ln sine x plus ln cos x minus ln tan x. So I have decomposed this function. You understand? This function is easy to differentiate right now. You understand? That is the aim of decomposing a natural logarithmic function before finding the derivative. Thank you for watching the video. Please, I would like you to subscribe to this channel if you have not done so, and also follow my page. Also, please, if you have any question, you can drop it in the comment box. I'm going to attend to it. Thank you very much.